Okay, geometry fans, our topic for today is rectangles. This is the second topic that we have with quadrilaterals. Parallelograms was our last set of notes. So before we start, let me tell you your joke of the day. What did the digital clock say to the grandfather clock? And the answer is, hey, look, Grandpa, no hands. All right, so what are we going to do? We're going to use information about a quadrilateral to determine the best name for the quadrilateral, and we're going to use coordinate geometry to determine the best name for a quadrilateral. All right, so properties of rectangles. First of all, we're going to draw one, and I'm going to pick 4 points here to make it. And the points I'm going to choose, I'll do -6, 4. I'll call that point A. I'll do 5, 4, and that's point B. Let's do 5, -2, and that's C. And -6, -2, and that's point D, -6, -2. All right, and then let's go ahead and connect it. So trace these lines. There's our rectangle right there. Now, we've already talked about the definition of a rectangle. The definition is a quadrilateral with 4 right angles. So when you see something like that, you know right away that is a rectangle. The other thing about a rectangle is that this is a parallelogram. So all the properties of a parallelogram are also going to be true. Now, I'm not going to write everything down, but let's just discuss them. The opposite sides, both pairs, will be parallel. Okay, you can eyeball this and say, yeah, these are zero slopes, these are both undefined slopes, those are parallel lines. The opposite sides are going to be congruent. We could count this and show that they're the same distance. The opposite angles are congruent, they're all 90. The consecutive angles add up to 180, they're supplementary. Now the diagonals, let's go ahead and draw those. I'll use the ruler this time. The diagonals connect the opposite points in a quadrilateral. Okay, so we've got AC as a diagonal, and then we have DB. Now, they are going to bisect each other. This is what we learned about parallelograms, that these two pieces will be the same because it gets bisected, and then these two pieces will be the same because this gets bisected. All right, so what's different about a rectangle? Why do we call it a rectangle and not a parallelogram? Well, one thing was that all the angles are 90. All the angles are congruent. However, there's also something special about the diagonals. They bisect each other, but there's more. All right, so here's what we'll do. Let's look at the slope, the midpoint, and the distance of the diagonals. So the slope for AC, I'm going to count the rise over the run. I'm going to start here. I'm going to go down and then to the right. So I'm going to go down 1, 2, 3, 4, 5, 6, and then I'm going to go right 4, 5, 6, 7, 8, 9, 10, 11. So the slope was down 6. Now down is negative, and then right is positive, so it's -6 over 11. That's the slope of AC. Now for BD or DB, I'm going to start at point D. I always start and I go left to right. So I'm going to start here. I'm going to rise. Now this time my rise is 6 and my run is 11 again. But when I rise, it's positive. So it's 6 over 11. Now you might notice these are opposites of each other. -6 11ths, +6 11ths. But that's not a relationship we're going to really pay attention to. Okay, so nothing special about this. Now the midpoints should be the same because the diagonals bisect. So we can test that. For AC, we add the x's. Now the x's are -6 and +5. So -6 plus 5 over 2, comma, add the y values, 4 plus That's a negative 2 over 2. And we simplify that, and what we get here is negative 1/2, comma. Now 4 plus negative 2 is 2, and then 2 divided by 2 is 1. So it's negative 1/2, comma 1. That's the midpoint of AC. The midpoint of DB, I'm going to add the x's, negative 6 plus 5 over 2, comma, add the y values, which are negative 2 plus 4. Negative 2 plus 4 over 2. And look at what happens. This is negative 1 over 2, so it's negative 1/2, comma, negative 2 plus 4 is 2. 2 divided by 2 is 1. So notice you get the same midpoints. Now that's not special really, because this is a parallelogram. A rectangle is a parallelogram. So this means the diagonals bisect. Okay, so we'll say bisect diagonals. Alright, so again though, that's not different from a parallelogram. So what makes a rectangle different? Well, now let's do the distance. Let's talk distance. Now distance is the big square root. The distance from A to C is we subtract the x's. So I'm going to take 5 minus negative 6. Subtract the x's, square it. Now I'm subtracting a negative, so I have to put minus, and then this is negative 6. Then I subtract the y values. That's negative 2 and positive 4. So negative 2 minus 4 squared. Now I'm not going to go through the whole process here because I'm kind of running out of space. But we'll get square root. This becomes plus plus. This is 11 squared. And then this is negative 6 squared. When we add all that up, we're going to get the square root of 157. Okay, now if you do the same thing for BD, if you do the distance of BD, you are going to get the exact same thing. So what happens here, let me go to my picture. I'm going to label this again. I had 1 mark for both of these, and I had 2 marks for both of these. But what happens is we just showed, okay, you can check me on this on BD, but I promise you that's going to be the same. The distance of AC and the distance of BD are the same. That means the segments are congruent, so all of them, all the pieces are the same. It's not just these two and these two, it's all 4 of them are going to be congruent. That's what makes a rectangle different. The diagonals of a rectangle are, and the big symbol here, they are congruent. That's not true for a parallelogram, but that's always true for a rectangle. Now the other thing that I need to point out, and this is really important here, if we look at the triangles, you have 4 triangles that get created by the diagonals. Notice, I'll take the bottom one here. Notice that 2 of the sides are congruent. Now the third side is different, so it's not equilateral, but what happens here, that triangle is an isosceles triangle. And as a matter of fact, if I look at a different triangle, how about this one here on the right, notice that that's also 2 sides congruent. That's isosceles. What happens here is that all the triangles are isosceles. You get 4 isosceles triangles. Now, when triangles are isosceles, I'm going to just put this on the side, don't forget that when you have isosceles triangles, that we know if 2 sides are congruent, then we know that their opposite angles are also congruent. So what happens is you know that things are equal, and that's going to help us when we try to solve examples, when we solve problems. Okay, so let's look at number 1. Quadrilateral EFGH is a rectangle. Find X, Y, Z. Now, when I look at this, I like to start with the side lengths, and I usually start with the outside stuff. I see 6Z plus 8 is segment EH. Now let's see, I don't know the top, and I don't know the bottom, but I do know the right side is 50. They tell me that. And the other thing is, this is a parallelogram. A rectangle is a parallelogram, so we know opposite sides have to be congruent. So right away we can say 6z plus 8 equals 50. 6z plus 8 equals 50, and now we'll solve it. So we'll go minus 8. So 6z is 42. Divide by 6, and we get z is equal to 7. Alright, so there's z. Okay, now let's look on the inside of this picture. 3x, notice that there's no degree measure next to it. So 3x is a length, and it's the length of this piece of diagonal right here. Y degrees, that's an angle. 37 degrees, that's an angle. 21 is a length of the diagonal, of half the diagonal. Now, what did we say about the diagonals of a rectangle? They are congruent. So that means all of these pieces are the same. So 3x and 21 are equal. So we're going to say 3x equals 21. There's the equation. Let's go ahead and solve it. Divide by 3. X equals 7. So we got z equals 7. We got x equals 7. All right, they're the same. Now the last one here, let's go ahead and do we got to find y. Now let's see, y is an angle measure here. That's the angle. The 37 is down here in this triangle. 37 is down here in this triangle. Let me go ahead and label this triangle. I'll put a color here. This is isosceles. In an isosceles triangle, you know the angles opposite the congruent sides have to be congruent. Okay, so if this is 37, I'm going to rewrite that, then so is this angle here, 37, 37. Because if I draw arrows to the opposite angles, that's what we got, 37, 37. All right, I know this is kind of hard to see. We're missing the angle at the top of the triangle. However, you know that all three angles of a triangle always add up to 180. So if I take 37 plus 37, I get 74. And then I'll subtract that from 180. And that gives me 106. Now here's the thing. This angle's 106. But notice that's a vertical angle with the y. These are the same. So if this is 106, y equals 106. So y is 106 degrees. And that's the answer for number 1. Okay, so what we'll do here, I'm going to stop the video for a moment. That's the end of part 1, and then we'll come back, we'll look at the other examples for part 2.